think of this talk as a bridge between neuroscience and daily life. How the autistic body and brain operate in everyday life. We usually describe autism in terms of behaviors or social traits, but much less attention is paid to the underlying body-brain systems that produce those behaviors. Key regulation systems, which occur across the lifespan, are rarely explained in everyday conversations. So, I will walk you through a small selection of these high-impact body-brain processes. Interoception is about internal signals, while alexithymia is naming emotions. Inertia is challenges with starting, stopping, and switching. We will discuss 3 kinds of movement differences: stimming, OCD-like loops, and tics. And finally, we will look at the Autism-ADHD combination profile. We will also look at what it means, why it matters, and how to support it. Before we go into the science, it's worth naming some of the quiet biases in autism research. First, research in this area traditionally used autistic participants who are easier to test, those who speak, follow instructions, and tolerate sensory demands, sit for longer periods of time, have better motor skills. But then, research findings from these studies are generalized to the entire autism spectrum, even though many autistic profiles are understudied. So, some of the sensory, motor, and regulation patterns you may see in real life are not absent, they're just underrepresented in research. We probably have not even uncovered all the sensory-motor nuances going on, as a huge chunk of autistic profiles are missing from research on autism. Second, most research looked at Western environments, quieter, less crowded, lower density. India and much of Asia have constant sound, shared spaces, heat, and unpredictability. In addition, movements like neurodiversity paradigm seem to tell us that the solution lies mainly in fixing the environment. But we can't always redesign the natural environment or public spaces, especially in crowded cities or in a country of 1 billion people. So, strategies must adapt to real conditions. This talk is about understanding the science and then adapting it to your everyday reality. Coming back to our brain-body processes, let's start with interoception. Interoception is an important yet overlooked system in autism. My PhD co-mentor, Professor Carissa Cassio, is an expert in this area, and much of my understanding comes from her work. Interoception is the brain's ability to sense physical internal states, like hunger, thirst, bathroom cues, pain, temperature, fatigue. You can think of it as, can I feel what is happening inside my body? In autism, these signals may be faint, delayed, or intense. An autistic may not feel hunger until they suddenly crash. Bathroom awareness may come very late and result in random incontinence. Pain or illness may go unreported because the signal isn't strong enough. Heat and humidity can lead to overwhelm if temperature signals don't register early. And, because early stress signals aren't felt clearly, an autistic can go from fine to overwhelmed in a matter of minutes. Many autistics also fluctuate between these states, depending on stress, sensory load, and fatigue. This variability is a key reason why regulation can change dramatically across the day. Let's look at how we can support interoception challenges. The theme here is External structure helps fill in where internal cues are unreliable. Scheduled meals and hydration prevent energy crashes before they hit. Cooling routines matter even more in warm climates. Timed bathroom breaks help when cues arrive too late. In crowded or noisy environments, where exits aren't easy, we can use micro-pauses, a few seconds to reset by closing eyes, leaning on a stable surface, or stepping aside. We can also make use of simple check-ins. Bottom-up check-ins ask, what does my body need right now? Hunger, thirst, temperature, bathroom, pain, fatigue. No long list, just the basics. Top-down check-ins ask, how close am I to overwhelm? Traffic signals colors can help draw parallels. Green is steady. Yellow is rising tension. Red is overload, approaching. Both kinds are important. Bottom-up helps identify the specific body need. Top-down helps gauge how close the system is to overwhelm. Together, they support both sensory and emotional regulation. Next, let's talk about alexithymia. Alexithymia is about interpreting emotional internal signals. To understand this, let's first walk through how we experience emotions. Emotional awareness starts in the body. Every feeling first shows up as a physical signal, a tight chest, a racing heart, a heavy stomach, or sudden fatigue. The brain then has to do a few steps. First, separate the body signal from the emotion. Is this anxiety or stomach discomfort? Heat or anger? Fatigue or sadness? Next, notice that an emotional shift is happening at all. Then, identify and name it internally, finding the right word or sense of the feeling, connecting that to a cause or trigger. Only then comes the challenge of communicating that feeling outward to other people. Research suggests that for some autistics, emotions may be hard to identify, separate, or verbalize. They may know something is wrong, but unclear what. This is why autistics may feel emotions intensely, but struggle to articulate them. It's a processing pathway issue, not a lack of self-awareness. Supporting alexithymia means giving structure so the brain can translate body signals into meaning. We start body first. Describe the sensation first. For example, my chest feels tight, instead of immediately searching for the correct emotion word. Body emotion maps help connect patterns over time. For example, tension and fast breathing mean anxiety. Heaviness and slowing down mean sadness. High-level categories, like high energy or low energy, pleasant or unpleasant, may be easier in the moment than specific labels. And it's important to normalize delay. Many autistics recognize the emotion after the moment passes. And using both bottom-up and top-down check-ins gives a fuller picture. It is important that we support the physiological state first. Behavior is usually the endpoint of a confused or overloaded nervous system. Labeling can wait until the body is steady again. We've talked about interoception and alexithymia. Next, let's move to autistic and inertia. Autistic inertia is when the brain and body have trouble shifting states, starting, stopping, or switching. The question here is, can I start, stop, or change actions when I need to? A change in state requires motor planning, executive function, and sensory regulation. Autistics may want to act, but feel stuck until their system has enough regulation and energy to shift. Transitions are especially hard because the nervous system needs time to restabilize. My article in the APS Observer talks about autistic inertia in more length. To support autistic inertia, look at the friction points. We support starts by giving a very clear first step, reducing choices, and using external cues like timers. Stopping also takes effort. Soft stops, and letting the person finish a micro step, can reduce distress and prevent crashes. Also, the further the system is from the new task, the harder the shift. So, switching between tasks is easier when there's warm-up time or a simple bridge activity, something neutral, that helps the brain change gears without abrupt shifts. Lowering executive load is key to make transitions more automatic. And because inertia is partly a body state issue, movement helps the brain shift. Next, let's move to movement differences seen in autism. And here, we will cover 3 different ones that look very similar: behaviorally stimming, OCD, and tics. These 3 movement patterns often get mixed together, but actually arise from different brain circuits. Which means they feel different and require different supports, even when the behaviors look similar externally. We are all pretty familiar with stimming. Stimming is fundamentally a sensory motor loop trying to regulate arousal, attention, or sensory load. OCD compulsions look repetitive, but arise from anxiety-based circuits, not sensory regulation. The brain thinks, if I don't do this, something bad might happen. The action is driven by anxiety, not motor rhythm. It's like your brain notices an error that must be fixed immediately. Door must be closed as soon as a person enters a room. Backpacks and suitcases must be zipped up. My brain is so driven by that urge to fix a perceived error, it will not consider that I should not be zipping up someone else's backpack. Logic just flies out the window during an OCD compulsion urge. Tics are neurological disinhibition. They are involuntary motor or vocal bursts, brief and unpredictable. The tic movements happen to the person, not by the person. There is no regulation function, no emotional reward, and no avoidance of fear. Let's take a deeper dive into stimming. Stimming looks like rhythmic or patterned movements. It's automatic and often not fully conscious. Examples include rocking, flapping hands, and oral sound patterns. Earlier narratives claimed that all stimming was bad because it was purposeless. There was a lot of stigma around it. The current neurodiversity narrative has flipped that narrative, pointing to the regulatory aspects of stimming and saying that stimming is good. But then, this seems to imply that all stimming is good. It's not that simple. Stimming behaviors serve multiple functions. it is important to recognize and understand the function, rather than its appearance. Some stimming patterns truly help. They regulate energy and emotion. It supports focus and self-organization. It's grounding and helps with transition. Then, other types of stimming patterns are not helpful. It increases agitation, it becomes compulsive or hard to stop. It interrupts attention and daily functioning. For example, it becomes more difficult to listen to the other person on a Zoom call if you have an automatic competing audio stimming going on at your end. Stimming behaviors can also indicate overload or anxiety. There may be a sudden increase in speed, intensity, or repetition. There may be a shift to more forceful or disorganized patterns. There is difficulty pausing, even briefly. In addressing stimming, the key is always the same: support the nervous system first, and let movement follow. Helpful stimming should be supported. Others should be redirected to more organized options. Now let's turn to supporting OCDs and tics. A simple rule is that compulsions come from fear, tics come from involuntary bursts. Support the driver, not just the movement. For compulsions, the goal is to reduce the anxiety underneath it. Predictable routines can reduce the urge. Clinical methods like ERP can help. I have written about OCD for the Daily Californian. You can do a Google search to find the article. For tics, don't call attention to them, it may only worsen them. Reduce stress, fatigue, and social pressure. Quiet breaks, slower pacing. Some movements that look like tics may actually be medication-related, such as akathisia or tardive dyskinesia. These are involuntary side effects of certain antipsychotics or GI medications, so it's important to rule these out before interpreting a movement as a tic or a behavioral issue. The last item in today's talk is the co-occurrence of autism and ADHD. I've had the dual diagnosis of autism and ADHD since childhood. And about 30 to 50% of autistics also have ADHD. This dual diagnosis is often referred to, colloquially, as AuDHD. Everyone assumes that a dual diagnosis means that ADHD gets added on top of autism. But I have to tell you that living in a mind-body that is both autism and ADHD is like being pulled in two opposite directions at the same time. I've come up with a new neuroscience model to push the field forward. We make the case that it's not just addition, it's the brain rapidly switching between two different arousal gain states. The paper is currently under peer review, but the key idea is simple: the nervous system is juggling two regulation systems at once. This state switching can happen over seconds, minutes, or hours. The brain toggles between two very different modes: hyper-responsive one moment, and under-responsive the next. Sensory input may feel overwhelming at times, underwhelming at other times. Motor responses may feel clumsy or delayed because the feedback loops are working overtime to keep up with shifting demands. Some moments, the system is sensitive and needs predictability. Other moments, it needs stimulation to get going. The same person may seek stimulation, yet be overwhelmed by noise. They may crave routine, yet need novelty, hyper-focus deeply, yet struggle with low-interest tasks. Supports for AuDHD must match the mode the brain is currently in. First, expect variability. Capacity can change rapidly. Next, identify the mode. An autism-like mode needs structure and less input. An ADHD-like mode needs novelty and activation. Then, we match the environment to the mode. And, most importantly, we support transitions between the two modes, because that's where the real struggle lives. Interest is one of the strongest tools for navigating the ADHD system. Before I close, I want to highlight the main takeaway. Everything we just covered are body-brain regulation systems. When these systems are supported, autistic people do better. When they're misunderstood, mislabeled, or ignored, challenges look much bigger than they really are. The goal is simple: reduce the mismatch between the autistic nervous system and the world around them. When we support the system, we support the person. That's the bridge from neuroscience to everyday life. And of course, these 5 areas are only a small sample. There are many other areas in the sensory motor and regulatory space. Today I focused on a few high-impact ones to show how neuroscience can guide practical support across the lifespan.